So now we are going to be looking at some of these internal faults, okay? How to identify these faults and what actually caused these problems. Once we know all of this, then we'll be able to put strategies in place that will help us to prevent the problem from reoccurring again. So we are going to be looking at first. Remember, we said the internal fault could be associated with the winding, the bearing, the rotor, and the stator. Okay, so we are going to be looking at the winding in this case now. Remember, we said identifying the fade component alone is not enough, because anybody can look at the fade component and be able to some extent identify that this component is bad or has failed. The real thing is being able to identify what actually caused the failure of that fade component. So once we are able to do that, that will help us to protect our equipment from that failure causing event in the future. So we are going to be looking at the electric motor wind. That is, we are going to be looking at the winding with a view to understanding some of the failures and the causes, failure patterns and their causes. Okay. Remember, we said the quality of the power can affect the operations of the electric motor. So we are going to look at that. Then mechanical problems too can also result to the failure of the windings, okay, or any of the internal components, though we are looking at the windings now. Then the environment too, as we earlier outlined, the condition that is associated with the environment in which the equipment, the electric motor is operating, can also affect the integrity of the electric motor. So we are going to look at how all of this influences or affects the operations or the integrity of the electric motor windings. Okay. So now we are going to look at first, as you can see on your screen, this kind of failure. So evidently the windings the winding is burnt, as you can see on the screen. But if you look at this burnt winding, you will notice that there is a pattern on this burnt winding. So if you look at it, you see that these three set of coils, they are untouched. Why these ones, 1, 2, 3, 4, 5, 6, they are burnt. These three, the same thing, they are untouched. This set, burnt. This one, the same thing. This one, burnt. Are you getting? So there is a clear pattern. So how do we understand this pattern with a view to identifying what actually caused this kind of failure? Okay. Now, if you appreciate the way the windings are laid in the three-phase electric motor, you will come to understand that these three-phase, the three set of windings, they are placed in three different phase beds. Okay, they are wound 120 degree electrical degree from each other. Okay, and they are the same winding. So if the motor, like in this case now, if it is starred, as you can see on the screen, if it is starred, that is all the ones, all the twos are connected together, or it could be all the ones that will be connected together, as the case may be. But in this case now, all the twos, that is the finish end of each of those winding, the W winding, the U winding, and the V winding, they are connected together or starred. Okay, that is what we also have here now. Okay, so remember, to the terminal block, you have that. So the motor terminal, we have the three phase or the three lines, line 1, line 2, and line 3. Are you seeing it? So that is what we have here: line 1 into U1, line 2 into V1, and line 3 into W windings. So peradventure that we have a single phasing of the electric motor, which means that there is a loss in a single line. That is one of the line, there is failure in one of the line. No power coming into the motor through one of these lines. It can be any of the lines. So let's assume that we are looking at failure on the line L1. So this failure could be as a result of an open fuse. Okay, so once there is an open fuse, it means that if the fuse is open on this line alone, it means that these two other lines will be supplying voltage or power to the electric motor, while this one is open, so it could not supply, and no power will be able to return through this line. Okay, so what we'll have, if you look at the connecting wire, the winding connection here, you see that what you have, assume this one is fade now, it means that this line is open. Nothing can come in, nothing can return through this line. So what we have is line 2 and line 3. Okay, so if you have line 2 and line 3, it means that the current, okay, will flow through W winding and then return through the V winding. So also too, it will flow through the L2, okay, through the the V winding and then return through the V winding. And if that happens, we know that the amount of current that will be flowing through both windings will multiply. Unlike in the former case where we have all the 3 lines, that all of them will have to cancel at this neutral point or the start point. Okay, so this W1 and V1 will now be subjected to excessive current. That is, more than normal current will now flow through each of these 2 windings. Are we getting it? So once excessive current flows through each of these windings, remember they are made of copper wire, which is made up of resistive material. Coppers, they are resistive in nature. So as current is flowing through it, the I square arrow effect will set in, okay, thereby increasing the heat dissipated on these windings. Okay, so if that is sustained, that single phasing is sustained for some time, remember there is load too. There may be load on the electric motor. If it is sustained for some time, you will see the burning of those 2 sets of windings, while one is intact, the one that has the open face. So if you see this is a signature of a single phasing on the electric motor. So once you have been able to identify that the problem is single phasing, okay, so what you need to do is to protect the electric motor against single phasing in the future. So we can have single phasing protection on the electric motor, such that once there is a phase failure, the 3 lines will open and switch off the electric motor. So the protection can be designed to be looking at the phases. So once there is phase failure, it opens up, okay, and then trip the power supply to the electric motor. So at times too, when your contactor, if you have contactor on the line, or yes, contactor, if the three poles, they are not closing at the same time, maybe 2 is closing before 1, you see that before the 3rd one closes, okay, it may have single phased for some time, and if that is repeated over time, it can result to this kind of thing. So that means that we also need to check to see that our contactor, they are operating normally. The 3 poles, they are closing at the same time, even your breakers. Okay, so you can check the description below for the inspection and testing of switches, contactors, and breakers. Okay, so that is the single phasing of star connected electric motor or windings. Okay, this is the pattern. So when you see it, you know clearly that what you are looking at is a fault condition caused by single phasing. Then if you look at this too, you will see that the pattern has changed. Okay, so instead of having those 2/3 of the windings, as in this case now, you see that it is 2/3 of the winding that is burnt. Okay, 2/3 of the entire winding, because it's only this one that is left. In this case, it is 1/3 of the winding that is burnt. Are you getting it? As you can see on the screen, it's 1/3 of the winding that is burnt. So if it is 1/3 of the winding that is burnt, what you should look at first is to look at the connection at the terminal block to see if the electric motor is data connected. So if it is data connected, of course, that will explain what has actually happened. It is still single phasing. Okay, so remember we said single phasing can be as a result of an open fuse. That is the easiest explanation, or a broken line to the electric motor itself. So if that happens, what will happen is that, assuming it's line 1 that is open, okay, what will happen is that it's line 2 and line 3. So you are feeding just one set of winding. It is entering and returning, entering and returning. Are we getting it through just a single winding in the system? So that sustained overheat, as we explained earlier, will cause the burning of this V winding. Okay, so that will show up as just a 1/3 section of the winding being burnt on the electric motor itself. So this pattern shows us clearly that the problem that we are having, or we had, was single phasing. So what we need to do is to protect the electric motor against phase failure or single phasing. Okay, so that once we have phase failure in the future, that will automatically shut the equipment down and protect our equipment for us. So shorted winding. Okay, there are different types of shorted winding. It could happen between the phases. It could also happen within the same phase. Okay, but what we are seeing on the screen now is between two different phases. That is why you have this kind of high blast between two different phases. Okay, so now if you look at this installation, and that is how all electric motor they are wound, you see that the stators, they are insulating papers, okay, are placed in the stator before the windings are placed, which means the winding does not have any business or connection with the stator itself. Then if you look at these different phases, you see that this insulating paper is placed to separate them, as you can see here, separate this phase from this phase. So in essence, this means that the U phase does not and is not supposed to have any business or connection with the W phase, okay, because they are completely separated. You only have connection at the terminal connection. Are we getting it? At the terminal block. So that is where you have connection. Well, if it is starred or it is data, but within the winding there is no connection. Okay, so now if this insulating material is not the strength or the insulating capacity is not high enough to withstand the voltage difference between these two phases, what will happen? You see that it will eventually fail. Okay, it will eventually fail, and once it fails, that will mean that the insulation between the phases has dropped, and that can cause such a blast as you see here, okay, between the two different windings, or coil, that is two different windings. Okay, then again, if there is contamination, there are contamination. It could be that the grease that used to grease the bearing, some of them may drop, the lubricant may drop onto the winding and then trap dust. Dust, they kind of increase the conductivity of those lubricants, okay, and that can cause the bridging of the two phases. Then voltage surge also. Remember, the insulating material that is used to separate has its own breakdown voltage. Beyond that breakdown voltage, it will fail. So if that surge that came in is high, okay, higher than that is breakdown voltage, it will also fail. Are we getting it? So if we have a power quality monitor on our system before, what we need to do is to look at the power quality pattern or the input power quality pattern to see if there are surges. Okay, so if we suspect surge, then we can put surge protector on the line to the electric motor, so that when there is surge in the future, the line will just open up and protect your electric motor. Of course, excessive vibration too, which can result from poor workmanship if it is not properly bound, as you can see here. Okay, you have to band and then put insulating varnish to see that the winding is firm and strong, so that when voltages are passed or voltage is passed through the windings, they will not vibrate. So if it vibrates, that can result to something like this. Okay, one of the phase can vibrate and make contact with the other phase. Since the insulating capacity has been reduced, that can cause failure. Or it can also happen when you have the vibration coming from an external fault condition. Okay, that is maybe misaligned bearing or coupling that is not properly made, increasing the vibration of the electric motor. We have soft foot on the electric motor, increasing the vibration of the electric motor. All of those can contribute to. So it's not left for us to try as much as possible to determine the possible cause and prevent the motor from such failure in the future. So we are going to remember, we said that shorting can happen even within the same coil or the same winding. Okay, so each of these coils, it can happen, as you can see here, is a turn-to-turn short. So once there is a turn-to-turn short, that will reduce the resistance of that particular coil. Are we getting it? So once that happens, and at that point of short, okay, the continuous arcing and the rest can result to the burnout of the winding at that particular spot or point of short. That is what we are also seeing here. So the same kind of set of problems can result to turn-to-turn short. As we explained earlier, it's the same thing: contaminants, vibration, or voltage surge. Okay, remember, there could be that's more than one set of coil that make up winding. If there is a short in one of the winding, this is how it will look like. Okay, one of the winding will just be burnt. So the same thing too: contaminants, vibration, and voltage surges can result to poor workmanship too. Once the insulating copper wire is not properly handled, it can also result to something like this. Okay, then winding grounded at the edge of the slot. So remember, we explained earlier that this insulating paper, it is lined on the slot before the placement of this insulated copper wire or conductor. So which means that this insulated copper wire is not supposed to have any contact with the slot or the yoke of the motor. But when we have things like what we explained before, voltage surge, contaminants, vibration, or anything that can compromise the insulating capacity of those insulating paper that is used, okay, that can cause that grounding at the slot and at the slot edge, and that is what will result to this kind of blast. So when you see it at such point, okay, you know that there is a ground fault already at that particular position. So it could also be that that it could be caused also by poor workmanship, as we earlier explained, because if this placement of this insulating paper is not properly done, okay, the possibility of maybe it's too short at the edge, it's too short at this edge, okay, the possibility of the winding coming into contact with the edge during operation is very high. Are we getting it? So all of this could be the causes, and of course, once we identify that the actual culprit, okay, that is what you are seeing on this insert, then we want to prevent it from happening in the future. So the same thing, such compromise can also happen within the slot of the electric motor. So that is what we are seeing here, okay. So the insulating capacity of the insulating materials that is used has been compromised, and there is a grounding in the slot coming into contact with the yoke, and that is why you have this kind of blast, okay. So the same thing too, you need to check if it is caused by contaminant, caused by voltage surge, by looking at the power quality as at that particular point in time, okay. Then at the connection point too, or the connection end, you know, this end where you have all the winding leads, okay, the winding terminals out, that is where you have the lead outs connected, okay. So they are connected here, so there could be shorts in this particular point, and that is how you see it at those connection end. And it could also be as a result of using the wrong material, poor workmanship, okay. Voltage surge can also cause such, and contaminant, as we said earlier.